Let's try this. I'm going to plot some current voltage characteristics for three components. For a resistor, this is a box full of resistors of different sizes, so we're going to use one of those. A filament lamp, which hopefully is working, and a diode, which I've got clipped between two crocodile clips in that component holder. To do this, I've got a power supply, a battery pack, because this will be useful for the diode particularly because it can't take too high a current. And I've got a current sensor, which is wireless, and a voltage sensor, which is wireless. They're ammeter and voltmeter respectively. Now the reason I've got these is that I'm going to plot a current voltage graph using the iPad, but we'll get to that in a minute. This last device is called a variable resistor. And the first thing I'm going to do, in fact, is connect up a circuit with this variable resistor or rheostat connected so that you can see exactly what it does. So hopefully you can see me connecting this up. I'm going to first connect it with the power supply switched off. To the DC terminals, we'll go for about maybe 7 volts. And I'll turn it around that way. And let's start with the bulb, because this will be a clear indication of what it does. Don't worry about how I'm connecting it up, just worry for a minute about what it's doing. Now it might look old, but fingers crossed it still works. Just need to tighten that a little bit. Let's turn this on. Okay, so you see the bulb is only lighting when the variable resistor or rheostat is set, so the sliding control is at this end. So what I'm doing here is I'm adjusting the resistance of the circuit within which the filament lamp sits. It's a nice way of being able to adjust the voltage across the filament lamp without, and hence the current through it, without having to do it stepwise. Now, as it happens, this power supply would allow me to do it continuously, but I'm going to use the variable resistor in any case. Let's begin with the resistor. I'm actually going to use this resistor, which is a 15 ohm resistor, because these resistors are too big, as it turns out, to get a current reading which is good enough to actually see clearly. So this is a 10 million ohm resistor, 10 meg ohms, down to 47,000 ohms. So I'm actually going to use a smaller resistor. The question is, did you see the edit in the video? I'm going to connect this to the circuit so that, again, I can vary the voltage across it using this variable resistor. I'm now going to put the voltmeter, which is this wireless device, in parallel with the resistor. And I'm going to use this current sensor, and I'm going to need to be careful how I connect this. I want it between the resistor and the variable resistor terminal here. So now I've got this set up so I can measure the current and voltage across the resistor, or the current through and the voltage across. Here's the iPad. I'm going to turn it on or reset the software, and we're going to connect both the current, the ammeter, and the voltmeter. And I'm going to actually select current up here for reasons that I won't bore you with. Select graph. And what it gives me is a plot of current on the y-axis against time on the x-axis. Now, what we want on this occasion is to plot current against voltage to show how the current through the component, in this case a resistor, varies with the voltage across it. So what I'm going to do is I'm going to start data collection. So we'll start in the middle here. Watch what happens as I move the variable resistor I'm going to stop, and I'm going to rescale the axes because the current's quite small. And you can see that we get roughly a straight line. Don't worry about the jaggedness. Roughly straight trend line through the origin. Both voltage and current are considered positive because that's the current flowing one direction around the circuit. If I switch the terminals around and do the same thing again. Watch what happens now. Again, we're going to start in at 0, 0. Let's see if I can get the other part of the graph. So that's, again, straight line through the origin, roughly. Now, because the conventional current direction is opposite, and I've not changed the ammeter connection or the voltmeter connection is round, both are considered negative. If I put both up, you'll see that you get the classic resistor IV characteristic straight line through the origin. Don't worry about the slight variation. I'm measuring quite small currents, and things like touching the apparatus, moving it around is going to have some effect. And also, the variable resistor itself is not perfectly smooth. You're always going to get some fluctuations with such small currents. We're going to do the same for the filament lamp, and I'm actually using this smaller one rather than the large one. And again, same setup. I'm going to plot the current voltage graph by sliding this along. So remember, what we're doing is we're varying the voltage across the filament lamp and seeing how the current behaves as I do that. Okay, so what I'm getting, it's not perfect, particularly at small currents. We seem to be having a problem, or the current sensor seems to be having a problem with those. But you can see the general shape is fairly steep, and then the gradient decreases as we get higher. So the current starts off increasing quite sharply, but then levels off. The rate of change of current with voltage becomes less. Let me do another run with the terminal switched round. So I'm going to just press start. We should, again, start near the origin, not far off. And I'm going to, again, move the variable resistor control like that. And again, we're getting, it's relatively steep to start with and leveling off. I am going to do that one again. I'm not happy with that. So let's try one more time. Starting hopefully near the origin. You can definitely see, whatever's going on down here, the gradient is certainly steeper in this region. And then we get the gradient decreasing like that. Now, if I put both sides of the graph on, you can see, with the exception of this middle area, we're not getting the steep section as nicely as I would have hoped. But we definitely can see that characteristic S shape in there for the filament lamp. So what this, and again, I'm improvising here, what this should look more like, if this pen actually works, is something more like this. Now that's not worked out perfectly. It's added an extra line in. But what you can see is we should be getting the current coming up here like that. And then there should be, rather than it spiking and then coming across, it should be more S-shaped, okay? But that at least makes it plausible. And just think, with a data logger, I can do that in seconds. Get some idea of the behavior. If you were going to plot this, do this by hand, measure current with a voltmeter, measure current with an ammeter, voltage with a voltmeter, you know, it would take much longer. You'd have to plot the graph by hand. So data logging can really make things quicker. Next, the diode. Okay, the diode. You'll notice it's not very spectacular looking. A diode is pretty boring, really. It's very useful in the sense it lets current only flow in one direction, but it's not like a light emitting diode, which emits light and looks pretty. It's not very interesting. A bit like a resistor, in fact. So let's put it down here and do the same thing. We're going to plot current against voltage. So let me just set this up so that we can plot what we want. Now, I want you to think what you expect the current, or how you expect the current to behave in a diode. Now I don't actually know which way around I've got this connected. So I guess we're going to find out. So I'm going to turn on, start the data collection. We're going to start down here and I'm going to increase the voltage stepwise up to, it's probably up to about 2.5, 3 volts. So we're not getting anything really, are we? That's, okay, I zoomed in too far there. That's just the fluctuation of the sensor. You see this 0.0005 amps, 5 milliamps. That's just fluctuations within the sensor. Watch what happens if I switch the terminals around though. So in short, there's no current flowing, no matter how high I put the voltage. Let's plot now with the current going the other way through the diode. In fact, let me just bring this back. Same thing. We're going to start down here. Watch this. No current, no current, no current. And then suddenly we get an increase. Okay, so we got nothing, nothing, nothing. And then just short of 0.6 volts, the current starts to increase. And if I continued, I don't want to overload the current sensor, we could get a larger current now. In fact, I might redo that. I might turn the voltage up a little bit. I know the current sensor can handle 1 amp. So let's do that again with a larger current potential. So again, nothing, and then we get the current spiking. Okay, so you can see 0 current and then shoots up at about 0.6. If I put both parts of the line on, you can see 0 current in one direction, so the diode doesn't allow current to flow in one direction, and then the other direction it starts conducting at 0.6. I hope that's been useful. Thank you very much.